Welcome to the e-learning program for Vortex Flowmeters. After completing this module, you will be able to recognize the main parts of Vortex Flowmeters and product variants, specify the different options such as explosion protection, temperature compensation, and communication types, describe multi-sensor devices and their advantages. The latest generation of Vortex Flowmeters is setting new standards in Vortex Flow metering. The following features are completely new. Excellent vibration compensation. The meter outputs as volume flow, temperature and pressure compensated volume, mass or energy flow. The operating concept. Typically, a Vortex Flow meter consists of the following main components: spool piece, piezo sensor, transmitter. The interaction between the piezo sensor and the transmitter is very important, as the raw signal from the sensor is often very noisy due to pulsation, vibration, and other hydraulic effects, and the transmitter needs to effectively filter out all of the interfering components to detect the correct flow signal. The new generation of VortexMaster used two types of sensors, one for standard temperature and one for high temperature. The ideally balanced piezo sensor is the heart of the sensor construction. To filter out noise and vibration at a very early stage, he uses a further two compensation piezos in addition to the two flow piezo elements. This makes the sensor signal very reliable and enables precise recognition of the actual flow signal. As mentioned in the Basic Technical Principles module, the vortex signal is not a clear sinus curve, but is affected by hydraulic noise and vibrations, etc. Therefore, it's sometimes difficult to detect the right vortex frequency without any dropouts or additional peaks. Conventional vortex flow meters tend to measure in the same range as digital devices, but often less precisely. In the illustration, you can see a complete spectrum analysis of the frequency range of a vortex flow meter, where the x-axis is the frequency range and the y-axis the signal amplitude. All of the larger and smaller peaks can be both the correct flow signal or noise. The challenge is to find the right flow frequency. Typically, the highest peak is the flow signal, but especially at low flow conditions, this may not be the case. A vortex meter without intelligent vibration control would pick up the highest peak and translate it into volume flow. The graphic shows the spectrum analysis of the compensation piezo elements. Here we can see that the highest peak from previous spectrum analysis is mainly vibration. The other graphic shows the spectrum analysis after compensation of the vibration effects. Now the previous second highest flow peak is the highest peak now and will be chosen by the device for flow computation. The sinus picture looks noisy, but the flow amplitude is now higher than the noise and will be detected by the device. Digital signal processing ensures maximum measurement precision and reliability. The accuracy is plus minus 0.65% of the rate for liquid measurement and plus minus 0.9% of the rate for gases. All meters are wet calibrated in water. The standard temperature range is from minus 55 degrees centigrade to 280 degrees centigrade, which is minus 67 degrees Fahrenheit to 536 degrees Fahrenheit. A high-temperature version for up to 400 degrees centigrade, 750 degrees Fahrenheit, is available. The meter sizes for flanged meters are DN15 to DN300, that is, half an inch to 12 inches. Wafer-type meters are available from DN25, 1 inch, to DN150, 6 inch. The standard pressure rating is PN40, class 300. For non-standard devices, a pressure rating of up to PN160, class 900 is possible. The sensor housing is made of stainless steel 1.4571, which is ASTM 316 Ti. The casted meter bodies are made of CF8C. Hastelloy C or duplex, super duplex bodies are available on request. The DIN wafer design has 65mm laid length for direct exchange of standard orifice plates. The ASME design is available with longer lay length. The basic meter is now more basic. It is supplied only with a 4 to 20 mA output, and it provides HART communication in the absolute basic version. This means that the display, HMI equals human machine interface, and digital outputs such as pulse output, frequency output, new, and contact output are now options. The VortexMaster transmitter contains housing, terminal board, 2 different versions of the main board, optional HMI, display module, back and front cover. The transmitter housing is available in aluminium and stainless steel. Depending on the option for digital output, the terminal board and the number of lead routings in the housings are different, meaning that a digital output cannot be implemented retrospectively without changing the complete transmitter box. The VortexMaster can read in values from the following if they're connected to the same bus by HART. Pressure transmitters or temperature transmitters. The prerequisite for this is that the connected device must send its information in burst mode. This means that it continuously sends the primary value. The HART input can be combined with the analog input, meaning that it is possible to connect a maximum of 2 remote sensors to the VortexMaster, one via HART and one via analog input. Important information: a maximum of 1 unit should be on the bus in burst mode. For the HART input, the following applies. A 250 ohm resistor must be implemented in the power loop of the VortexMaster, and the pressure transmitter must use the same plus or minus power line. Both transmitters must have their own power supply. Analog input is optional. The VortexMaster can use it to read in values from pressure transmitters, temperature transmitters, gas analyzers, densiometers or Coriolis mass flow meters which are connected in line with the remote sensor output. As already stated, the analog input can be combined with the HART input, meaning that it is possible to connect a pressure transmitter and a gas analyzer to the VortexMaster to enable pressure compensation and parallel net methane flow computation. Important: both devices must use independent power supply units. The analog input of the VortexMaster must be in line with the power loop of the connected remote sensor. The second cable entry of the VortexMaster can be used ideally for the analog input. Remote transmitters can be used in various installations. Typically, they're used where the measuring points are not easy to reach. Alternatively, they're used for atmospheres with high ambient temperatures. In contrast to the Trio Whirl FV450VR, where we're limited to 10 meters, equal to 32 feet maximum cable length, the new VortexMaster transmitter can be installed further away from the sensor. It can be installed up to 30 meters away. Cable lengths of 5 meter, 10 meter, 20 meter and 30 meter are available, and the cables can be shortened by the customer individually. Improvements have also been made in the temperature range. High-temperature sensors can now be connected with remote transmitters as well. As an option, the VortexMaster can be equipped with an integral temperature sensor. This is the PT100 sensor. It is integrated in the piezo sensor unit and can be used to control the temperature limit and/or to compensate for the temperature impact on liquids, gases, or steam within the meter. In saturated steam in particular, where it's sufficient to know the pressure or temperature, the integral temperature measurement helps the customer to save additional costs for installation of pressure or temperature transmitters. Using the FSV450 with the interface for a pressure transmitter, the integral PT100 can be used to calculate the mass or energy as well as for overheated steam or for gas standard calculations. Sometimes the compensation calculation is performed with an external flow computer, and as this is no longer necessary here, this investment can be saved as well. The piezo sensor is used to measure the actual volume flow. The integral temperature sensor measures the steam temperature. The transmitter is in steam mass flow operating mode for saturated steam. The steam curve for saturated steam is implemented in the transmitter, thus it knows which steam density is related to which temperature. For example, at a steam temperature of 230 degrees centigrade, the density is 13.96 kilograms per cubic meter. The volume flow is multiplied by this density to obtain the mass flow in kilograms per hour. This value is mapped to the output of the analog device, HART communication, or per digital output as frequency output or pulses. In the FSV450 VortexMaster, not only is the saturated steam calculation implemented, but the calculation for overheated steam as well. Once the device registers that a pressure transmitter is connected to the VortexMaster, this value is also used for correct steam calculation. Vortex Flowmeters can cope with demanding applications. For these cases, as Vortex Flowmeters with 2 sensors and 2 completely independent transmitters as engineered solutions. Both can be realized as integral or remote versions. The temperature of the medium is the same as for standard meters. High temperature versions are available as well. The X design is the same as for standard meters. The installation lengths are the same as for standard meters, allowing the customer to replace a single sensor device with a dual sensor one. Dual sensor devices are available in remote design as well. The minimum line size for the installation of the second sensor is DN50, 2 inches. Dual sensor devices are often used for a triple validation, which is a 2 out of 3 measurement, meaning that 3 sensor signals are recorded and evaluated in parallel. If one signal deviates from the others, the faulty sensor can be easily identified and exchanged during the next regular plant shutdown. A further application is: equip one transmitter with analog or HART communication and the other transmitter with field bus communication. This allows for a later plant upgrade. One of the special advantages of the design is that sensors and transmitters are completely independent of each other. Let's summarize everything in a checklist before moving on to other topics. What have you learned so far? You've become familiar with the main parts of Vortex Flowmeters and product variants. You can recognize the internal temperature compensation and its fields of application when you provide advice to your customers. You can also list the options for connecting remote instruments such as a pressure or temperature transmitter via HART or analog input. You can describe multi-sensor devices and their advantages.